Hi guys, so today the video is on carcinogenic agents, also called carcinogens. So what is a carcinogen? Carcinogens are agents that damage DNA, increasing the risk for cancer development. So causes of cancer development. Cancer formation is initiated by damage to DNA of stem cells. The damage overcomes DNA repair mechanisms, but is not lethal initially, which allows cancer propagation. If it was lethal, the cell dies, no formation, no formation of a neoplastic cell eventually. But if an unhealthy damaged cell survives, only then that cell can proliferate to formation of like more of its kind, which are even more unhealthy and damaged, which is what we're going to see in the scheme later. Um, Like we said, carcinogens are agents that damage DNA. Important carcinogenic agents include chemicals, oncogenic viruses, and radiation. Um, DNA mutations eventually disrupt key regulatory systems, allowing for tumor growth and progression. That is spread. Disrupted systems include proto-oncogenes, tumor suppressor genes, and regulators of apoptosis. Cancer-causing agents are endogenous and exogenous. Endogenous are the inherited germline cells, like problems in these germline cells, which can be inherited obviously because they are germline cells. These cells are either containing certain mutations or chromosomal aberrations. Then there are the exogenous agents, where we talk about chemical agents, physical agents, and biological agents. These are the agents that we usually refer to as carcinogens. This is the scheme that I was talking about. So, in this scheme, we can see we have to mainly focus on the main event, which is permanent DNA lesion. Also, like you can either call it DNA lesion or DNA damage, which leads to formation of an initiated cell. But what really leads to this formation? It's the carcinogenic agents and the endogenous um, factors that we talked about, like DNA mutations, chromosomal aberrations, and germline cells. So, any kind of carcinogenic agent eventually leads to formation of this permanent DNA lesion, leading to formation of an initiated cell, and from that, multiple um uh, cycles of proliferation division leads to formation of these super damaged unhealthy cells, which are neoplastic. So neoplastic cells, which leads to formation of a neoplasm eventually. Could be malignant, could be benign. That's the bigger picture. This cycle shows the process of carcinogenesis, and that what I just talked about is the bigger picture. But obviously you can see other parts of this cycle of this flow chart, which is like more details, I would say. Okay, so chemical carcinogens. Many of human cancers are caused by chemical carcinogens to which we are exposed in many ways, like ingestion, inhalation, and direct contact. All chemical carcinogens need to be highly reactive electrophiles that react with nucleophilic sites in the cell, such as DNA, RNA, and proteins. Chemical carcinogenesis involves two steps: initiation and promotion. Like we saw in the previous image, initiation is the exposure of cells to carcinogenic agents causing DNA damage. This can result in one of three fates: DNA repair, or cell death, or permanent DNA damage, which leads to formation of an initiated cell. Promotion is the mutated initiated cell passes its DNA damage to its daughter cells that eventually develop to a pre-neoplastic clone. Now, these clones proliferate and acquire additional mutations that can result in malignant neoplasm. Basically, neoplasm. Don't focus on the malignant fact, just pre-neoplastic, I'm so sorry, pre-neoplastic clones end up into, not end up, but like transform into neoplastic cells or neoplastic clones, because they keep acquiring mutations. Why do they keep acquiring mutations? Because a cell which is damaged is at a high risk to acquire more damage if it doesn't die. It doesn't die, it still keeps living, and it'll keep acquiring more and more damage to its DNA, that is mutations. And so it'll reach a state where it's not dying, and it's just on a, like on a hyperdrive to keep replicating with all that damage. So that leads to formation of the neoplasm. Types of chemical carcinogens. Chemicals that cause initiation can be classified into direct and indirect acting carcinogens. Acting carcinogens, carcinogens that don't require any metabolic activation to become activated, that is, alkylating agents. Indirect acting carcinogens, chemicals that require metabolic transformation to become active, producing ultimate carcinogens. The activation is usually done by cytochrome P450 dependent monooxygenase, but can also be due to combustion, like in cigarette burning tobacco. Most of the chemical carcinogens are indirectly acting ones. Example is benzopyrene, formed during high temperature combustion of tobacco in cigarette smoking. As you know, that in a normal cigarette, there, like a normal cigarette smoke, it's not just um, tobacco. I'm so sorry. Like in normal cigarette smoke, tobacco is called carcinogenic, but like tobacco has many carcinogenic chemicals in it. It's not just one, it's not just benzopyrene. There are like loads and loads of these carcinogenic chemicals, which is why cigarette smoking or smoking tobacco is like so injurious to health. Not just the fact that it's smoke containing carbon compounds, but also like specific compounds released from burning tobacco. Promoters, agents that can induce tumors from initiated cells but are non tumorigenic by themselves. They act by stimulating cellular proliferation. Example, unopposed estrogen stimulation in endometrium and breast tissue. This is an important table of chemical carcinogens. It has a lot of carcinogenic agents and the associated cancer they can cause, and some extra comments. Uh, another so there was another column that was there in this table which I could not add, so I'll just tell you what it was. So the carcinogenic agent in that I could not add was nickel, chromium, beryllium, and silica. They can cause lung carcinoma. Remember, especially remember silica from occupational exposure. Physical carcinogens. You can divide physical carcinogens into two categories. Non so in physical carcinogens, you majorly talk about radiation, and radiation can be divided into two types: non-ionizing and ionizing. Under non-ionizing radiation, we study UV radiation, ultraviolet. So it originates mainly from the sun rays. Associated cancers are skin cancer, which are namely squamous cell carcinoma, basal cell carcinoma, and skin melanoma. And out of these, melanoma is the most dangerous one. Um, then squamous cell carcinoma, and then basal cell carcinoma. Basal cell carcinoma rarely metastatizes. It can be locally invasive versus squamous cell carcinoma, which has bit more metastatic potential and definitely very high invasive, locally invasive potential. Um, Whereas skin melanoma is also called malignant melanoma, and it has a very high metastatic potential. Classifications according to wavelength. Um, right. So UVA radiation is 320 to 400 nanometers, which is not so harmful. UVB is 280 to 320 nanometers. This one is the most harmful. And UVC, which is 200 to 280 nanometers, is filtered by the ozone layer, thankfully, and therefore it is not something that we need to worry about as long as ozone layer is there. Pathogenesis. The carcinogenicity of UVB is due to pyrimidine dimers formation, covalent cross-linking between bases, mainly in thymidine residues. When these are produced in a moderate amount, the cell is able to correct the DNA damage using its repair mechanisms. Upon severe and prolonged exposure to UVB, the repair mechanisms are overwhelmed and cancer can develop. See, usually this is how it works, like we talked about in chemical carcinogenesis also, that there are three possibilities in general. Um, the cell can either repair the DNA damage, or the cell dies from DNA damage, or the DNA damage doesn't kill the cell, but the cell is not able to repair it either fully, and so that damage persists. The cell persists and is able to proliferate and carry on that damage further into and like give it to the daughter cells as well. And the damage keeps accumulating. So that's the idea here also. And that was the idea in chemical carcinogenesis as well. Light skinned people are at greater risk for this kind of cancer. Xeroderma pigmentosum is a hereditary condition in which this repair mechanism is non functional. So, yes, the people with xeroderma pigmentosum are definitely at very high risk of developing skin cancers, but you should also remember that xeroderma pigmentosum is a rather rare condition. Now, ionizing radiation. Types of ionizing radiation are, sorry, so types of ionizing radiation are electromagnetic, X-ray and gamma rays, and particulate, alpha particles, beta particles, protons, and neutrons. Yeah, sorry. So associated cancers are myeloid line leukemias, papillary carcinoma of thyroid, mainly in children. Pathogenesis. The ionizing radiation hits water particles, which leads to formation of hydroxyl radicals. This leads to double chromosomal breaks, which is like the main mechanism, or single chromosomal breaks. The idea is her chromosomal breaks and other major mutations which the cell cannot repair. You need to remember that ionizing radiation causes damage to DNA mainly by production of hydroxyl radicals and not by direct DNA damage, which is often what people think. The chances of direct DNA damage by any kind of radiation are actually pretty low because DNA is a very small structure inside the cell. Just imagine how small nucleus is, and within that tiny DNA, the probability of it getting hit by ionizing radiation is pretty low. So this is the major mechanism via hydroxyl radicals. Right. So biological carcinogens. DNA and RNA viruses. In biological carcinogens, we majorly talk about viruses. First is HTLV1, which is human T cell leukemia virus type 1. It's an RNA retrovirus. It associated cancer is adult T cell leukemia, lymphoma. Pathogenesis is a retrovirus with tropism to CD4 T cells. So it's associated with T cell neoplasms. The next is HPV virus. It's a DNA naked virus. It's sexually transmitted. Now, it's important to remember that there are 12 high risk HPV types. HPV 16, 18, 31, 33, 35, 39, 45, 51, 52, 56, 58, and 59. Two of these, HPV 16 and 18, are responsible for most of the HPV related cancers. They are like the most important. You can also remember 31 and 33. HPV 16 and HPV 18 account for about 70% of all cervical cancers. So it's like super important to remember. These are like very, very important. Other than that, honorable mentions, I would say, you should remember is HPV 6 and 11, because they cause about 90% of genital warts. Now, genital warts is not, are not, it's just an infection, okay? It's not neoplastic. But to know that HPV has um, subtypes which cause something else, like a normal infection, which is not neoplastic, it's important. What cancers are we talking about? Squamous cell carcinoma, vulva, vagina, anus, and cervix. Adenocarcinoma of cervix as well. Then we have EBV, Epstein-Barr virus. It's a DNA virus from the herpes family. Associated cancers are nasopharyngeal carcinoma, endemic in China, Burkitt lymphoma, the African form, CNS lymphoma, and oral hairy leukoplakia in HIV patients, and Hodgkin lymphoma. Hepatitis B and hepatitis C virus both cause chronic liver inflammation that can develop to cancer. It's a known fact that you study in general pathology that chronic inflammation puts a tissue at a high risk of like developing neoplastic cells. The chronic inflammation can progress to neoplastic process happening in the cells. And this is what happens in a lot of conditions, especially infection related conditions, like we can see here. So chronic liver inflammation that leads to development of cancer eventually in the liver. Associated cancers are hepatocellular carcinoma. 80% of the cases are viral related of hepatocellular carcinoma. Pathogenesis is that the major mechanism is immunologically mediated chronic inflammation that causes hepatocytes to die, which leads to regeneration, compensatory proliferation, and over time, like all of these processes are happening to some extent, and over time, to genomic damage. It has to reach there somehow. Human herpes virus 8 associated cancer is Kaposi sarcoma. It's a type of tumor, it's a tumor of endothelial cells arising as cancer of lymphatic endothelium, vascular endothelium forming vascular channels filled with blood, giving the tumor its characteristic bruise like appearance. Pathogenesis. There are three types of patients that can suffer from Kaposi sarcoma. There are the Eastern European males, where the treatment is simple excision of the tumor. AIDS patient, because they are so immuno deficient, uh, it's easy for them to develop this infection, um, and like easy for them to get HHV8 infection and l- development of Kaposi sarcoma from then. And the treatment for this would be treating the virus and busting the immune system. Transplant patients, again, they are immunosuppressed. They are on immunosuppression treatment, and reducing the dosage of that immunosuppressive treatment will be the treatment of choice in this situation. uh, Although, like in biological carcinogens, we mainly talk about viral agents. It's important to remember Helicobacter pylori, which is a bacterial infection. So Helicobacter pylori is a gram-negative bacteria found commonly in many populations, both developed and developing countries, in high percentages. Where it's found in the stomach. So associated cancers are gastric adenocarcinoma and gastric maltomas. What Helicobacter pylori does is that it like its tropism is in the stomach, and someone with this infection uh, develops peptic ulcer disease, and these peptic ulcers, because of this chronic inflammation, eventually progress to development of cancer. Pathogenesis, chronic inflammation that induces increased epithelial proliferation. There's damage, there's healing, um, and all of that basically leads to neoplastic conversion of cells. Okay, that's it. Thanks.